Hi ladies, so as we are starting to review for our small quiz tomorrow covering sections 5.1 and 5.2, we do have the review worksheet, and remember these are the same problems that you will find on the quizzes that is linked under the assignments of Plan Book. So these should not be a new surprise, but you can find them in many places. So without further ado, problem number 1, perform the following operation using the multiplication property of exponents. Well, that says if you are multiplying things with the same bases, you are going to add your exponents. So first of all, we see we have 2 times 9. No matter what we're learning, that will always give us 18. And then we've got a with an invisible 1, right? Just like every invisible denominator is 1, every invisible exponent is 1. So a to the first times a to the fifth. We add our exponents, we get a to the sixth. And then b to the sixth, b to the negative second. Add our exponent, 6 plus negative 2 is 4. And again, lastly, c to the invisible first, c to the invisible first. Altogether, we have 2 c's, so we get c squared. Problem number 2. Now we are using our division property of exponents. This is our quotient property, our quotient of powers. And so we go through the exact same process. So we've got 8 over 16. Again, that will always give us 2 in our denominator, or a 1/2 altogether. We won't put the 1 in the numerator unless we have to, but we'll see what happens. So then we've got x squared in the denominator and x cubed in our numerator. If we subtract our exponents like we do using our division property, we are going to end 3 minus 2, we get a positive 1. So we get x to the first in our numerator. And then we've got y to the first divided by y to the sixth. Now we take our exponents and we take 1 minus 6, we'll get negative 5. Or we can put it straight in the basement to keep it a positive 5. So we have y to the fifth. And lastly, we have z to the fourth over z to the negative third. 4 minus negative 3 gets us a positive 7. So we finally get x z to the seventh over 2 y to the fifth. Number 3, from the following operation using the power rule of exponents. Well, that says that we use quote-unquote distribution. So don't forget to take your constant term, or your, I guess not constant, but your coefficient to that power as well. A lot of times that's the easiest thing to forget. And then we take it to every single term. So we have 3 to the fourth, x to the, so this is our power of a power property, which says that we multiply. So we have x to the 16th. Y to the fourth, z to the negative 2 times 4 gets us negative 8. Now the only thing we need to move to our denominator to make it positive is that z to the negative 8th. So then we'll erase that and throw it underneath, make it positive. And then one more piece, 3 to the fourth, we know what that number is. We need to evaluate that. 3 to the fourth is 81. So I have 81, x to the 16th, y to the fourth over z to the 8th. Number 4, we are using a combination of rules here. So I notice right away that we have a bunch of parentheses, so that means that we're going to have to distribute that exponent. So I will have 2 to the third power, a to the 2 times 3, so taking a power to another power, a to the sixth, b cubed. So that was just our first set of parentheses. Our second set, again, we distribute, so we have 5 squared, a squared, b to the negative 10th, multiply, and c squared. Now we are going to use our product of powers property, which says that we are going to add our exponents. So 2 cubed and 5 squared, those are just normal looking numbers. 2 cubed is 8, 5 squared is 25. So we have 8 times 25, which we'll do here in a second. And then we've got a to the sixth, a to the second. That'll give us a to the eighth. We've got b cubed, b to the negative 10th. When we add those exponents, we get b to the negative 7th. And then our c squared is just along for the ride. Now we can take that 8 times 25. Notice we will get 200. So we have 200, a to the 8th, and c squared. Now our b to the negative 7th, we need to move our b to the positive 7th to our denominator to make our answer be in final simplified form, which can never include negative exponents. And then in problem number 5, I would start by simplifying what we have inside parentheses first. So we've got 3 over 3 squared. That means that we have 1 3 left over in our denominator. We have x over x squared, so same idea, 1x left over in our denominator. Y over y to the fourth, we subtract, we have leftovers in our denominator, y cubed, and then z and z to the negative first. So remember, we've got 1 for that exponent, so 1 minus negative 1 gets us a positive z squared. From here, we need to take all of this raised to the negative second power. So we're going to go ahead and distribute that. So I have z to the negative fourth over 3 to the negative second, x to the negative second, y to the negative sixth, because we multiply those exponents. Everything has a negative exponent, so everything needs to move either to the top or to the bottom, depending on where it is. So we'll have 3 squared in our numerator, and you know what? That's 9. So 9x squared y to the positive sixth all over z to the positive fourth. Last one, number 6. We are multiplying two numbers in scientific notation. So we first we quote unquote combine like terms. So 2.1 times 6.3, we get 13.23 times 10 to the, let's see, oh, that's right, we just need to add our exponents. So times 10 to the negative 5 plus 14, 9th. Now, this is not in scientific notation. This is bad news. Remember that the number you're taking times 10 to the whatever power needs to be between 1 and 10. 13 is not between 1 and 10. We move our decimal place once to the left. So we remember MLA and Mrs. MLA, in fact. So move left, add 1 to our exponent for the power of 10. So we get 1.323 times 10 to the 10th. Lastly, from this section, we have a plane moving at a speed of 885,000 meters per hour. If it needs to travel a distance of 9,582,000 meters from Tokyo to London, how long will the trip take? Now, remember, distance equals rate times time. They gave me my distance and my rate. I need to find time. So we remember that our distance, our 9,582,000 equals 885,000, which is our rate times our time. What we'll do is go ahead and convert both of those numbers into scientific notation so they're a little bit easier to work with. So we have 9.582 times 10 to the 6th equals 8.85 times 10 to the 5th times t. So naturally, to get t by itself, we have to undo the thing attached to it. Well, it's attached by multiplication, so to undo it, we use division. So we divide by 8.85 times 10 to the 5th on both sides. So we're dividing by that. And then, just like we do when we use multiplication, we work with these kind of piece by piece. So we can first plug into our calculator 9.582 divided by 8.85, and we get about 1.08. Times 10 to the, well, you're just dividing two things with exponents, so you're going to subtract your exponents. So times 10 to the first. Now, since it's only in times 10 to the first, and this is in the context of a real-world problem, we can go ahead and convert that back into decimal notation or standard notation. So if we're multiplying 1.08 times 10 to the first, we can call that 10.8 hours. Alrighty, go ahead and watch the next video to see what happens in section 5.2.